Welcome back to Gate Baba. In this lecture, I am discussing submerged arc welding and its applications. So up to now, we have seen that the electrode is coated with flux material, right? That means the direct bonding between electrode and flux. But in this case, we are using a bare electrode without coating, and we are providing the flux material from outside. It is not bonded initially. Okay, the flux material is provided from the outside and external flux material is covering the welding arc. So why we have to cover the welding arc? That means we are protecting the welding arc from surroundings. If it is exposed to surroundings, what will happen? It will react with the oxygen and forms oxides. That will be a danger because oxide's melting point is higher than the base metal, so that we cannot weld the base metal, right? That's why you have to get rid of these oxides, so that we are submerging the arc. That means we are submerging the weld pool in the flux material. So this is all the flux material. By the way, the composition of flux material is, we can use calcium oxide or calcium fluoride. Okay, so this is the general flux material we are using in submerged arc welding. This is straightforward to arc welding, but the only difference is the flux is externally supplied and electric arc is produced between consumable electrode and workpiece. Here the electrode is consumable, not consumable. It is consumable electrode. So the arc is producing between consumable electrode and a workpiece material. So the consumable electrode is fed by roller mechanism. That means it's a guiding mechanism to feed the wire, nothing but electrode wire. And there is a flux feeding mechanism also there. It is governed by gravity only sometimes. Here you can see the real picture of welding. Here they are joining the two pipes, very large pipes with submerged arc welding. You can see the amount of flux material they are using, lot of flux material, and the thickness of electrode is very small, and that means the electrode material is small. Even though we are using large amount of flux material to protect the arc from atmosphere, so that is the only reason we are using high amount of flux material, the basic reason. And there are some lots of reasons, I will be discussing those also. Okay, now come to the parameters of this welding. Okay, and we are using a current range of 1000 to 2000 amperes. Okay, and it can be possible to weld up to welding speed of 5 meter per minute. This is the highest welding speed that can be achievable in all welding process. Okay, 5 meter per minute, all welding fusion process only. Okay, 5 meters means I can weld 5 meters per 1 minute, so that is very huge. Okay, and then come to the thickness that it can handle. It can handle up to 10 to 40 thicker materials. That means for high thickness materials, that means 4 centimeter thickness material workpiece can also be welded by this method. Okay, here we are using consumable electrode, so directly we can say that we are using DC reverse polarity. Then only the heat produced at electrode is very high, that means 2/3, and at workpiece it is only 1/3. If the heat produced at electrode is high, then only the electrode will be consumed. Otherwise, it consumed very slowly. And by the way, the deposition rate, the main point, the deposition rate is 20 kg per hour. That means the welding electrode is consumed by 20 kgs per single hour. So that is huge amount of electrode material is feeding to the cavity. So the cavity is very large here and the electrode material is very thinner. Okay, and then come to the advantages or some technical issues of submerged arc welding. We know that arc will be submerged under flux. So what happens if arc is submerged under flux? The first thing is heat transfer losses are minimized. We are protecting weld pool from atmosphere so that heat losses can be minimized. And the second one is heat concentration on workpiece will be increased. So heat concentration is increased. Okay, and then come to the third one. These are two straightforward answers, interrelated answers. Okay, and then for third advantage of using flux material is depth is more. Very high depth materials can be welded. We know that the thickness ranges are 10 to 40 mm. Very high thickness materials. That means 4 centimeter thicker materials can also be easily welded without any hassle. And by reducing the splashing, liquid metal weld spatter can be minimum. Here we are not using the electrode rod in the air. We are confining the electrode rod within the flux material. So the splashing is neglected. And because of this splashing neglection, we will get no spatter. That means no weld marks on the workpiece. The workpiece after welding is very cleaner after removing the flux material from the surface. Okay, and then come to the next point, that is slag inclusions can be minimum. Slag inclusions are also very minimum. And then come to the next point, that is we are using DCRP. Okay, that means the electrode is consumable. This is characteristics, not advantage. Consumable electrode, because we are using DC reverse polarity current, then only there is a consumable electrode, otherwise it is non-consumable. Remember that thing, I have told you many times, these DCRP and DCSP differences. Okay, please be note why I am stressing those things. Those are very important concepts while solving the questions, theoretical questions. Okay, and high welding speed. This is the highest welding speed attained by arc welding. That means fusion welding. I am not comparing with resistance welding or chemical welding. I am just comparing within the arc welding zones. Okay, this is the highest speed that can be possible with only submerged arc welding. And then come to the next point. This technique can only be used for flat position. This is a limitation. Okay, this is the limitation of submerged arc welding. We can only use this welding technique for flat position. You know what is flat position? I discussed that thing in the previous lecture. Okay, I can't use this in a vertical up or down position. I can't use this in overhead welding. So the only thing is flat position only. Now come to the next point, and that is HAZ is more. That means heat affected zone is more. Here the heat will be distributed throughout this workpiece up to here. In this also up to here. So that's why the heat affected zone is very high, because we are confining the heat within the weld zone. We are not allowing the heat to lose. So the first point, what is it is telling, heat losses are minimized. That means because of minimum heat loss, the heat is confined within the material, so that the heat affected zones will be more. Okay, now come to the application part. The main applications of submerged arc welding, nothing but SAW. Submerged arc welding can also be written as SAW welding, short form. The SAW welding are fabrication ship hulls. This is the main application. You put 100 stars over here. Ship hulls, because it is that much of importance it has. Many times ESC asked this question. Okay, ship hulls, match the following question. Then you have to directly mark it with submerged arc welding. And the second application is pressure vessels. In the diagram I shown you, the two cylinders are joined. These two cylinders are nothing but the pressure vessels here. So the pressure vessels joining application. And then the third application is Structural applications. These are the three main important applications of SAW. Among these three, you have to remember these two very high. Okay, and that is all about submerged arc welding. Thanks for watching.